Now let's take a look at how the syntax for a function pointer looks, and or rather also recall we can call a function pointer as a pointer to code, right? So let me first explain the syntax by using an example, and then it would become more clearer when we talk about why different pieces are the way they are. So what I have here, and again, we haven't taken a look at the syntax yet. What I have here are two functions, right? And if you notice, both of them are simple print functions that just prints the name of the function essentially, right? And the interesting thing here is that both the functions have the same exact return type and same exact function parameter footprint. So we have void, so they return nothing essentially, and then the function names, and then in terms of parameters that they take in, we have nothing, right? Which is what is here, which is what is here. All right, so we have essentially two functions, and let's say in the memory somewhere there is code relating to function 1, and somewhere there is code related to function 2. Okay, this is 1 and this is 2. Okay, and essentially these are called to printf, right? Same, printf, something like this. Okay, so that is what these functions are. Now the question is, can we somewhere else have some sort of pointer such that that pointer holds, let's say if this was, I don't know, dead, and this was the address beef, just for example, right? So can there be a location in the memory, a pointer so to speak, which can on demand hold dead, I mean the address of function 1, and can the dereferencing of P in that case lead to the function call or execution of the code here, right? And then later on, can we change this to become beef, right? Can we later on change this to become beef? And then, once we make it beef, when we dereference it again, we should have this code executed, right? And recall again that when we dereference a function pointer, the program counter changes to this. And when we dereference again, after this change is made, the program counter refers to this. And the program counter on its own just kind of fetches the instruction, the CPU increments it by 4, and so on and so forth, and it goes on reading the instructions, right? So then what we now have here, my claim is, this is how we declare a function pointer. And the syntax is very simple. The syntax is, you need to kind of mention what the function pointer, when dereferenced, will return, meaning in general, the function that it is pointing to, the code that it is pointing to, at some point the code will return. And return essentially means, for example, if we call this function, it will execute something and then return back, right? And typically it returns this value, this type of value. So we have to mention what type of value it is going to return, the function pointer, when dereferenced. And then we also have to mention what kind of parameters does this code take. Does it take any input? And that will become clear once we execute another example. But question is, does it take any input? If it takes, then what is the data type of that input, right? And then you need to give a name to the function pointer, right? And then the only key thing that we have to remember is that we put a star before the name and then cover it into parentheses, right? So data type, the return data type, brackets, star, name, then brackets, data types, data types of inputs, close parenthesis, and that's about it. And there has to be like a space here, and well, rest all, and there has to be space here, right? And this is a list, so it can be, many inputs. And we'll see all of this in a while, by the way, right? You'll also get chances to practice this in the assignments. All right, so look at what's here. We have the data type, which is void. Then we say, okay, open bracket star, close brackets, the name or parenthesis, open and close parenthesis. The name in between is the pointer's name. So instead of P, we have func underscore PTR for function pointer. Could be any name, but I chose to name it that. And then we say, hey, the parameter list is empty. All right. Now here's let me just clear this. So if this much is clear, notice what I'm doing here. I'm doing an assignment. I'm saying, hey, somewhere there was function one, it was starting from here, this location, and somewhere else there was function two, went until some point, and there's somewhere else I wanted you to create func um, func underscore ptr, and in that memory location, uh, let me kind of give this again the address of 4, and maybe give this an address of 114. Okay. So now what I'm saying is, hey, this func ptr here, could you please put the address of function 1? This essentially is saying take the address of function 1 and put it here. And this statement and this statement are same, right? So if you put an ampersand right here, or you don't put it, all the same. What you're not supposed to do is put parenthesis here. That translates to a function call. We don't want that, right? We are saying, hey, take this function, and whatever is the address of the function, assign it to funcptr. So funcptr is pointing to 4. On the next line here, we are dereferencing funcptr. And what is different from the pointers that point to data that we saw earlier is we do not put a star here for dereferencing. What we instead do is treat this like a normal function name and then just put parenthesis to make the call. And notice that in this parenthesis, we do not give any parameters. And the reason to us not giving inputs to the parameters here is because in the function pointer definition, we said that the function pointer takes no parameters. Right? And this will again becomes clear once we have a function pointer that points to functions with parameters. So yeah, this is as if we are calling function 1. And then what I do here is change the function funcptr to now point to the 114 memory location, which is address of the function 2, and then I execute funcptr again. Few things to note. This and this are same, except at this point, this is going to execute this function, and at this point, it's going to execute this function. Also remember again, no stars are involved here in terms of dereferencing the function pointer. No stars are required. You execute the function pointer or dereference it as if you're calling a function. That is the key. And let me run this example, and then we can conclude this video for now. And in the next one, let's look at function pointers with parameters. All right, so let me get rid of this, and let me go ahead and do gcc main.c, then a.out. And if you see this invocation or this execution point here has printed this, which is this, and this execution point, this execution point right here has executed this, right? And again, one final note, when we were calling or when we were executing function 1, somewhere there was a return statement at the assembly level or at the machine code level. That is why after executing the program counter jumped here, executed all of this, and here somewhere there's like a hidden return statement that the compiler infers. And so as a result, it returns back and continues executing this function, right? That's the flow. Uh, Hopefully, how to declare a function pointer is clear, the syntax for it clear, and how to execute or dereference a function pointer is clear. And in the next one, let's take a look at function pointers with parameters.